Welcome to the Solving Right Triangle Problems lesson today. So when I say right triangle, I do mean a right angle triangle, okay? So that's key for if you are going to use SOH CAH TOA, okay? So sine, cosine, tangent ratio equations. So I'm going to do a review of the stuff that we've covered so far. Like, for example, you should know how to label the sides. You should know how to calculate, so sine, cosine, tangent of some number. You should be able to find the missing sides. And what else? The other thing that we've covered is finding the missing angle. Okay. So that now that once you review all of those, we're going to tackle some more problems. So if you feel pretty confident with that material, you can jump to the first example down here when I get there. So just kind of read over this table and then move on to the problem. Okay, so we'll start with the first review question here. I want you to label the sides of this right angle triangle. So the first thing that you need to find is where's the important angle that you need to stand by. And so hopefully you see that it's right here. Okay, and so then you look through the triangle, and then this is the opposite side. And a lot of you guys have gotten used to like looking for this right angle here, and looking across that is always the hypotenuse. And then the remaining side is the adjacent. Okay, so I think we're all there now where we are labeling those sides. Okay. All right, then next I want you to get your calculator out, okay, and make sure it's in degree mode. So I downloaded a calculator that I can use on my desktop here so that you guys can see it visually. If it's something that you guys want as well, I believe that it's like this company, Casio, is offering a free download that you can use for the next few months while everyone's doing remote learning. So, but I find that it's almost too powerful, that it takes a little bit of working your way through to find even just this regular screen so you can do simple addition, multiplication, just simple operations, because it can do a lot of things like graph and so forth. So it's a great calculator, but it's almost like there's too much to it, okay? So anyway, let me know if you want instructions on how to download this. So anyway, have your graphing calculator out. I don't even know if it's in degree mode. I don't even know how to get it there. So actually I could probably figure it out. But anyway, I'm just using my regular calculator on my desk right now. And then so if I type in sine of 15, I'm just double checking right now. No, I'm not getting the right answer. So let's go and figure this out. So I'm looking at this calculator. I'm noticing it says rad right there. So I'm in radians. So I have to get myself out of there. So I'm just going to figure that out. Okay, if you're, I don't know, using this one, I figured out, okay, so I'm just going to go into setup. Okay, so when I go into setup, so I hit shift, I'm going to go, like the angle right now is in radians, so I need to go here and then change it to degrees. So I selected degrees, I'm good to go. I'm going to exit out of here, and now it says degrees. Okay, so if you type in sine, so let's smooth this up a little bit. If you type in sine 15 on your scientific calculator, your phone. Okay, so I just had to make another adjustment here, but if you type in sine of 15, there we go. That's the number that you should be getting on your calculator. So if it's your phone, if it's your computer calculator, scientific calculator, just make sure you're in degrees so that as we go through, you're calculating out the same values as I am doing when I'm going through, okay? All right, so we've labeled the different sides, so let's actually go through and calculate the sine of 33. So again, sine 33, I should be getting that value there. So I'm going to round to 3 decimal places as well. Okay, so you should be getting 0.544639, etc. You want to round to 3 decimal places. Some of you were having issues with rounding, so I'm just going to review that as well here. So again, 3 decimal places. This is the spot. This is the number I want to keep. Okay, everything left of it I want to keep. This is the first number that you're going to drop off. Okay, so that where that arrow is pointing is what's going to decide if you round up or stay the same. So since it's a 6, okay, so 5 or greater, you are going to round up. Okay, so you get 0.545. Okay, so that 4 became a 5. All right, go to the next one, and the next one, do the same thing. Calculate them out and double check that you're getting the same answer as me. Okay, so again, we've used sine, so now we're going to use tangent 18. Calculate our answer out. Okay, so again, if you drop your calculator, always double check if you're still in degree mode. Okay, so I wrote out a few extra digits here, but again, we need to round to 3 decimal places, so we need to keep this 4, and then we're going to look at the next number. Okay, so it's 9, so that's greater than 5, so we are going to round up this value to there. Okay, and then we drop off the rest of the values after that. All right, so let's do cosine 25. Okay, and there's our number. Okay, so again, I carried a few extra digits, and I'm figuring out that, all right, I need to keep this number here because that's 3 decimal places, 3 after the decimal. And then I'm looking at the first one after that. There we go, it's a 3, and it's not 5 or greater, so we're not going to round this number up. Okay, so we're just going to drop off the other number. So we're going to keep it as 0.906. Okay, and then the 307, etc. will get dropped off. Okay, so move on to, that's just, crunching the numbers in your calculator. So now we're going to actually get to questions where you're solving for the variable. So looking at this first one here, you're noticing that x is divided by 12, and then it should equal sine 35. So basically we need to solve for x here. So we're going to take the 12, since it's divided, and move it to the other side. Okay, and since it was divided, you're going to multiply it over on that side. Okay, and calculate your answer. So go to your calculator and type in, so I'll just clear the screen here. There we go. So 12 sine 35, and there's your value. Okay, and there's our number, but we would need to solve to 1 decimal place this time. So again, 1 after the decimal's right there. And then if you are looking at the next number, it's an 8, so we know we have to round up. Okay, so we'll end up with 6.9. Okay, and hopefully you realize you're finding a side, so if there were units, then you should write units, okay? So otherwise you could just write the generic units, okay? All right, so let's go to the next one, same thing here. We need to solve for x. It's a little trickier when you have the x at the bottom, so here it was at the top, so you can just keep the 12. Here you can't just chuck the 14 because then the x is still at the bottom of this fraction here. So I always tell people to just use this little trick method and just flip them both. Okay, so you can do that. Okay, so then make sure the tangent also flips as well. Okay, so we flip them both. Okay, again, if you're doing the same thing to the whole equation, then it's okay to do that. So now we have x at the top, and so what we're going to do is get that 14 that's divided and move it over here and multiply it over on that side. So where you multiplied is where that 1 is at the top. Okay, so we flipped it, we moved the 14 and multiplied it here. So back here, everything has a 1 underneath, so if it's not in a fraction, I can just write a 1 underneath, right? And that's where, and I flipped it, that's where that 1 came from. And now we're moving this divide 14 over, and we're multiplying it, we multiply it to the top. Okay, and let's calculate this out now. So we have 14 divided by, I would use brackets, tangent 23. Okay, and what value do I get? You should get 32.98. Okay, and again, this is a little bit trickier to round up, so you need one decimal place. So you need to keep this 9 here, that spot, and then we're looking at the next number here. So we're looking and seeing that 8 is greater than 5, so we do need to round up the 9, but then you can't write 10. So what you do is then you move over to this next number, and what's the next number after 32? You would write 33. Okay, so you write 33 and then 0.0. I always put that because then, yes, you have one decimal place still. Okay, so it's a tricky one here. When you're right at 9 and you have to round up the 9, just move over to the next digit and bump that one up. So we moved 2 up to 3, and now we have 33.0. Okay, and again, I wrote units because I don't know what units the side lengths are. All right, on to the next one here, where if I don't give you the equation, you have to set it up and then solve for the missing side. So again, what we're doing at the beginning here, label the sides, okay? And then from there, you got to figure out what formula that you need. So we'll go through those steps here. So let's just start off with labeling the sides. Okay, so always done at the important angle. So 48's there. That's the opposite. Okay, across from the right angle is the hypotenuse. And then we have the adjacent. Okay. All right, so the next step from there is you have to decide which formula that you need to use. So I'm going to list off SOH CAH TOA here. Okay, so I have SOH CAH TOA listed there. So now I'm going to go through and make a decision as to what formula I should use here. So again, we would label our sides. The side that we do have is adjacent, so I'm just going to check off all the adjacents. Okay, opposite, we don't need to find it. We don't have it. Okay, so we're not going to make a check mark. But hypotenuse is the one, yes, we do need to find, so it's important. So check off all the hypotenuse. And you're going to find that, here we go. Oops, the cosine here is the one to use, okay? Okay, so we've decided that cosine is the right equation here. Let's go through and write the formula out. Okay, so again, formulas will always be provided, but you should get them memorized anyway so you can go faster. So from there, you need to fill in the formula. So again, theta is where that's the angle. Okay, adjacent we do have, it's 10 kilometers, and the hypotenuse is p. Okay, all right, so it's kind of like question B here where we have the variable at the bottom. So use the steps that you need in order to get the variable out of the bottom. Okay, just adjusting my pen here. Anyway, okay. Oops, that's the eraser. Okay, so let's get the p out of the bottom by flipping. Okay, so we're going to end up going cosine 48 degrees, and then the p goes to the top, the 10 goes to the bottom. Okay, and then a lot easier to move the 10 out of there. There it goes. And when you multiply by 1, you just get 10. Okay, there's your equation set up now. Let's get our calculator. So 10 divided by cosine 10 divided by cosine, it was what, 48? Okay, 48. Okay, and there's your answer. All right, so we get P equals 14.9447, okay? And then we need to round it up to one decimal place. Okay, so that would mean you need to have this 9. We're going to look at the first number after the 9, and it's not 5 or greater, so that means we need to just keep it the same. Okay, and in this case here, we do actually have units, so kilometers. Let's move on to the next questions here. So we are trying to find the missing angles now. So again, we found the sides, we found how to calculate the functions, we found out how to find the missing side, and now we're finding the missing angle here. So we always had to find something that was missing on this side, but now we actually have that number. We need to figure out what is missing here. That's the angle. Okay, so in order to do that, we need to solve our way out. So we're going to take this cosine and move it there. Okay, so remember the opposite of cosine is the inverse cosine. Okay, so that's how we're going to write it here. And we're going to calculate that out. Okay. Okay, so let's go to our calculator here. So on your scientific calculator, you should have, right, like look for where sine, cosine, tangent is. And then above it, you should have the inverse. So this calculator here has A, S, N. So it just has some I think they're using it as arc, sine, arc, tangent. Anyway, so it's the same. But yours should be like this -1. That's usually what the other calculators, or most of the calculators I saw that you guys are using in class. If you're using a cell phone, remember, I think you have to just hit second and then the cosine and you get here, or it actually might have already listed this button. Okay, can't remember. Okay, so let's go through and calculate that. So I'm going to hit shift cosine to get my inverse cosine here, and then I need 0.237. Okay, and there's the value that you need. Okay, so let's write that in. All right, and if we go back to figure out, okay, solve to the nearest degree, so that just means the nearest whole number. So again, we need to keep that 6. Look at this number here, and the 2 is not going to round it up, so we keep it at 76. And then because we're finding an angle, the units are degrees. Okay, so write those in for full communication marks. Okay, let's do the same thing here. Now we have tangent in the middle here. So same thing, I want to solve for b, but right now I have tangent on there, so I'm going to move it over here. And when I do that, I'm going to take tangent, change it to inverse tangent, and write 4/8 in the brackets. Okay, so let's go through and try that on our calculator. Sorry, just move this over here. So, so we have inverse tangent. Okay, there it is. And then I'm going to put brackets, 4 divided by 8. Brackets. Okay, enter, and that's the number I get. Okay, and then round it up properly. Okay, so I need a whole number, so I'm going to look at this number here. It's a 5. Okay, so we have to round up. So we get to 27 degrees. Okay, so a lot of you are still having issues rounding, so just practice those. I don't know, look online for some worksheets to practice. Usually it'll just be like 1 decimal place, 3 decimal places, round to whole number. Okay, but we're all having issues. So just practice that until you're perfect. Okay, all right, next one here. So this one takes the most number of steps. If I just give you a picture, can you go through and find angle D? Okay, so usually you have an angle inside, but I'm actually telling you angle D is a special angle, so you're going to stand there, label the sides. Okay, and then so what you could do here with this step here where you list off all the formulas is that you could just kind of think in your head, all right, instead of doing this, you can go and look at, all right, I have hypotenuse, I have the opposite, which of the 3 ratios, which one has that? Oh, sine does. Okay, so you don't have to go through this check mark step here. But if you like doing it, then go for it. Okay, all right, hypotenuse, I have hypotenuse, checking those. I have opposite, checking that, checking it here, but this one got both check marks. So we need to use the sine formula. Okay, so from there, Let's fill the formula in. So then we get sine. Okay, we don't know the angle, but I'm going to call it D, because that's the angle we need to find. Opposite is 5. You could keep it theta, it's fine. And then hypotenuse is 13. Okay, so we're going to go through the steps that we did with A and B. We're going to move the sine over because we need to isolate D. Okay, so the opposite of sine is inverse sine. Okay, so look at that, inverse sine. So I'm going to go shift sine 5 over 13. Oops, I forgot the brackets. Oh, we didn't like that. Okay, try again. Let's see if I can put them back in here. Bracket 5, good. There you go. Okay, write those in. So 22.61, etc. 8, and then if you round it to a whole number, you get 23. Okay, because there's 22, and then the 6 is what determines if it rounds up or down, and we need to round up. And don't forget your units, degree symbol. Okay, so now we're going to move on to the actual new stuff now, the word problems. So again, you should have being able to label sides, being able to find the angles, being able to find the sides, the missing sides, and be able to just use your calculator and so forth. You're in degree mode. Now we can tackle some word problems with all of this information. Okay, so like with any word problems, you should always try to draw a diagram to kind of visualize what it is that you have and what it is that you need to find. And with these problems, you're going to end up drawing some sort of right angle triangle. Or you need to get to a right angle triangle because you might start with a triangle, then have to find a right angle triangle. And then from there, label the sides and then go through the steps of, okay, I'm going to use SOH CAH TOA somehow, either to find the missing sides or find missing angles. Okay, and because there were problems, make sure that you write a final statement. And and don't forget the units. So if it's supposed to be a side length, centimeters, kilometers, millimeters, and if it's an angle, don't forget the degree symbol. Okay, so I have the formulas here. I just want to introduce these two concepts, angle of elevation, angle of depression. So basically, I always teach this as, well, say you're standing here. So say you're standing here and your arm is sticking straight out like that, okay? There's the rest of your body. So your arm is sticking straight out with the horizontal here. Okay. All right. So if your arm's sticking straight out, and then so you have that horizontal, and then you lift your arm up, okay, then you created an angle here. Okay, so you start from a flat line and then you go up. So when you do that, that angle that you create from a straight line and moving your arm up, that's the angle of elevation. Okay, so in these questions today, you may be asked to find that. So you need to know what that means. So again, just think it as your arm is straight out and then you're looking up. Okay, so when you move your arm up from that straight line, that's the angle of elevation. Okay, the same thing applies here with the angle of depression. So same thing, let's say your arm is straight out like this. You have a really long neck this time. Okay, so your arm is straight out like this. So there's that straight line, and then if you drop your arm, okay, that angle that you make with that straight line is the angle of depression. Okay, all right, so let's kind of go through here and try these questions. Here is Noah, and he's flying a kite. Okay, so let's just go through and read through it. So he's flying a kite. He's let out 25 meters of string. His sister is standing 8 meters away. Okay, so 8 meters away from Noah, and she's directly under the kite. What is the angle of elevation of the string to the nearest degree? So I'm going to draw this picture out. So we have Noah here flying a kite. All right, and he's let out some string. Okay, so hopefully hopefully you've flown a kite before, if not, or seen someone flying a kite. So a kite will be kind of pushed out forward like that. The wind's pushing it, and then it's flying. Okay, so it won't be straight up in the air. I got an argument with a student one year where, no, it should be straight up in the air like this. I'm like, no, it's always like this. And his sister, so this is where Noah is, and then his sister is standing 8 meters away. Okay, so there's Noah, the sister, and she's directly under the kite. Okay, and then so let's label some things here. We know that there's been 25 meters of string. Sorry, my line was a little bit wobbly. It should be nice and straight. And the sister is 8 meters away, but she's directly below the kite. So when you're directly below like that, you will make a right angle here. Okay. And then it's asking, what is the angle of elevation? So that's the tricky part. What is the angle of elevation? Okay, so look for where you have the horizontal piece in your diagram. And then when you go up, you're going to make that angle of elevation. So I want to know the angle of elevation of the string. So here's Noah. Here's his horizontal here. Sorry, I don't have my cursor on. Here's Noah. Here's his horizontal here. So from the horizontal, you're going up to the string. So let's try a different color here. So going up to the string, okay? So when you make that angle there, that's the angle of elevation. So I'm just going to label here. This is the string. Okay, this is the horizontal here, right? Okay, and then now we just found the angle of elevation. So I'm just going to label that as well, right in here. Okay, so how do I do this without making it messy? Okay, I'll just kind of go like this. This is the angle of elevation. Right, so these are a relatively okay problem. It's just people struggle with just being able to draw the diagram, label things in the right place, and then go through and solve the problem. So just when in doubt, just try to draw something, kind of go through your steps and try to show some work. It's better than just leaving it blank, okay? All right, so from here, so once you have your diagram, I like to draw another one that's just kind of cleaner. So I'll draw one right over here. I'll make it lighter blue. Okay, so I'll draw the triangle here. So I have my right angle here. I have 8 meters here, and I have 25 meters here. And then what is it that this problem wants us to find? It wants us to find the angle of elevation. So you can call this, I don't know, x. Okay, so it's the angle in there. It's not the side, it's the angle. Okay, so from there, do what you've done before. So whenever you had your triangle, and here's the angle and so forth, you would stand here, look in, and then you have the opposite. You have the hypotenuse, and you would have the adjacent. Okay, so from there, make a decision. Are you going to use SOH CAH TOA or TOA? Okay, so let's do that, I don't know, like right underneath here. Okay, so again, if you want to save time, just kind of look at what sides you have. Oh, I have adjacent hypotenuse. Okay, so if I have adjacent hypotenuse, which one, like in this formula, in these formulas here, which one has adjacent hypotenuse? Oh, cosine does. Okay, so that's the one you use. Otherwise, if you, again, I know the checklist here works great for a lot of you, so you could do that as well. So here we go, hypotenuse, hypotenuse, adjacent, adjacent, okay. We've decided that cosine works here, so we are going to go through and write that formula out. Okay, so just going to try to give myself more space here, or whatever, I'll squeeze it in. Okay, so let's go through cosine of x, we don't know, we're trying to find that. Adjacent is 8, hypotenuse is 25, There we go. All right, we're going to boot the cosine over. Okay, again, you can hit inverse cosine 8 over 25. Oops, I forgot to do the brackets here. 8 over 25. There we go. Okay, etc. All right, so I'm looking back up at the question here. I need to find the angle of elevation to the nearest degree. So x here, I'm just going to write it here now. So x needs to be 71 degrees, okay? All right, and now we're going to also write our final statement because we have a word problem here. Okay, so the thing we had to find was, okay, so here, in order to get full marks for your final statement, you always have to use the keywords. The keyword here is the angle of elevation, so make sure you write that. So the angle of elevation for the string, okay, we were seeing from where Noah is standing at the horizontal, how much the string went up, okay, was 71 degrees. Example 2 now. So from the top of a cliff above the water, the angle of depression of a boat that's on the water is 15 degrees. How far is the boat from the foot of the cliff? Okay, so I want you to go through and draw this diagram out first so you can visualize. So again, cliff, do you guys know what that is? So just draw a cliff here, and there's some water. Okay, so you are, well, it's the same from the top of the cliff. So say you're hanging out, standing here. Okay, and from the top of the cliff, that is 108 meters. The angle of depression. So let's say our eyeball is right here. Okay, that's where our eyeball will be. Okay, so say we're laying down on the cliff here. Okay, so that's going to be the horizontal that you have to use as a reference. Okay, so from the top of the cliff, the angle of depression. So from this line here, we need to go down, okay? And that's how we make the angle of depression. Okay, so this isn't to scale, and that should have been straight, sorry. All right, so you are from the horizontal, your eyeball is say right there, you're looking down from the horizontal, okay? So that is the angle of depression right there. Okay, so that's key. You have to get the specific angle drawn properly in order for you to keep going with this question. So we're at the top of a cliff. It's 108 meters above the water, okay? And the angle of depression, so we have to kind of draw that in. So from looking straight across and going down, that's the angle of depression. So the angle of depression of the water on the boat is 15 degrees. So we can write that in here. Squeeze it in, or yeah, squeeze it in right here. Okay, so that angle here, this orange here, so this orange here, that's the 15 degrees from this dotted line to the green line here. All right, and there's a boat here. Okay, so let's just put our, let's put our boat here. Okay, sorry, I'll move that green line back. Okay, all right, draw our boat in. Again, that green line should have been straight. Okay, let's put our boat right here. Okay, all right, we want to know how far is the boat from the foot of the cliff. So again, if this, I don't know, cliff had feet, this is where the feet would be. Okay, that's the foot of the cliff. All right, and this here is the cliff, right? And this is you, but you're laying down and your eyeball is right there, okay? All right, at the dot. So, so again, just to read through the problem, kind of do it over and over again. So from the top of the cliff, that's 108 meters above the water, we have an angle of depression that is 15 degrees, okay? So looking straight out and then looking down makes the angle of depression. So that right there is 15 degrees. Okay, so the angle of depression of a boat on the water is 15 degrees. So you are looking from here, there's a horizontal, and then you look down at the boat. Okay, so when you did that, that angle is 15 degrees. Okay, and now I want to know how far is the boat from the foot of the cliff? So from here to here, that's what we have to find. All right, so now that we kind of have our visual diagram, let's get a stripped down diagram here, just the triangle. Okay, so again, you have a cliff that goes straight up, so you have a right angle here. And then, so this is important here, we have a 15-degree angle right there, okay, but it's not inside, so be careful, it is not inside of this triangle here, okay, it's on the outside here, okay, so from the horizontal. All right, what else do we know? We know the height of the cliff is 108 meters. And we know that this right here, from the foot of the cliff to the foot of the cliff to where the boat is here, that's what we have to find. Okay, so again, cliff to boat, right there. Okay, so right now, normally what we would do is we would stand at the important angle, but we have one angle, but it's on the outside of the triangle. So we have a situation here where we don't know the angles inside this triangle. But from what you've covered in the past, you should know that, so over here as well in this top corner of this triangle, hopefully you see that there is actually 90 degrees here as well. So if you know that this angle here makes a 90-degree angle, what would the angle in here be? Okay, so so let's just, I don't know, yeah, well, right. So we're just trying to find this dot right here, this angle in here. Okay, so we know that the angle, the whole angle in that corner is 90 degrees. So we're going to subtract the 15 and we get 75. Okay, and so we can write that in. All right, so all right, so now we're good to go. We have an actual angle inside of the triangle, so we can go through and stand at the important angle. We're looking in. This is the opposite side. That's the hypotenuse, and this is the adjacent side. Okay, so if we're going through the steps of figuring what formula we need to use, okay, do this in our head. We're figuring out that we need to find the opposite side, so that's an important side, and we have the adjacent side. Okay, so this is a tangent question that we need to solve. Okay, and also make sure that you are writing these formulas out. I'm seeing some people writing like this part here upside down, so the adjacents at the top and opposites at the bottom. It is important which way you do write it. I'm also seeing people write tangent and then they're writing the sine formula here. So again, just take a second to look at the formulas. Have them up here. Okay, but you can just have them somewhere on the side, post it up on your desk, your wall, etc. Okay, so from here, now that we know which formula to use, let's plug it in and start calculating here. So the tangent of, well, the angle that we figured out is 75 degrees. The opposite side, well, that's the side we need to find from the boat to the foot of the cliff. And the adjacent side is 108. Okay, and then we need to isolate x, so we are just going to boot this 108 over here. Okay, and calculate that out. So 108 tangent 75. 108 tangent 75. So again, I know that you just did a bunch of inverse sine, right? So just you got to pay attention to what it is you have to find. So here we're finding the side in this word problem. So you should not be using inverse, okay? Whenever you have to go find an angle, you should be using the inverse function. But if you're just finding the sine, you're just using tangent, okay? So just kind of, it's just a way for you to check to make sure you're on the right track. Okay, so 108 tangent 75, hit equal, and you get a really large number. So then you have, sometimes people worry because we've been calculating little numbers. But if you look at it, what are we doing? We're looking at a word problem with, we're on a cliff and then the boat's in the water. So if it's 400, does it seem okay? Yeah, it seems okay. Like cliff's 100 meters, right? X here is 403, and I'm just writing a few extra digits here, and then I'm double checking the word problem to see how many digits I'm supposed to round to. How far is the boat from the foot of the cliff to 1 decimal place? Okay, so that means I'm going to keep this 0 spot. I'm going to look at this number and go, oh, I got to round up because it's 5 or greater. So then you get a 1, and then I'm also looking for units. So we're looking here, we were working in meters. Okay, and it's a side that I had to find, so it had to be meters. You're not going to put degree here. All right, and to get your last final mark, make sure you write a therefore statement. So what is it that we had to find? What was the key word? How far is the boat from the foot of the cliff? Okay, so the boat is 403.1 meters from the foot of the cliff. Ooh, messy. Okay, all right. So that was a pretty tricky one, but I think the key here is if you just not quite understanding what angle of depression, angle of elevation are. Like if you're watching videos online, I think they sometimes some other people will use angle of inclination, angle of declination. So decline, incline. Okay, so elevate means to go up, incline means to go up. So sometimes they interchange the terminology there. And then depression means to go down, or declination is the opposite of incline, so they'll use that word as well. Okay,